So, good morning, everyone, and this is the ERCI webinar, Hydrogen in Rail, Myth or Reality. You will facing four perspectives exploring policy, rolling stock, infrastructure, and retrofit ahead of an interesting panel Q&A. My name is Lutz Hübner from Berlin Partner for Business and Technology. We are one of the members of ERCI, the European Railway Clusters Initiative. That brings me directly to a short introduction of ERCI as the leading media cluster of the railway sector in Europe. We are uniting 18 innovation-driven cluster organizations. We are operating in 17 European countries, and we are supporting in major, small and medium-sized enterprises, but we have also good contacts to bigger enterprises, to OEMs, for instance, to tier one suppliers, and to the research community, to other education institutions, the incubators and accelerators. What about our services? It is mainly in supporting small and medium-sized enterprises in detecting new market opportunities, in supporting them in partner matchmaking for research and development activities, in enhancing their visibility on the international level, in discussing with them innovative topics due to our ERCI task forces. You see the task forces which are just in operation. These are on cybersecurity, multimodal and logistics, and that what today might be important, the task force of green and sustainable mobility. We are providing some networking opportunities like this webinar series and workshops, networking events, fairs, and business trips. Not every week for sure, but from time to time. Our yearly event, highlight event are the annual ERCI Innovation Awards. Our this year's awarding ceremony will take place in Berlin during the InnoTrans. Yeah, to give an example of the work of the ERCI Task Force Green and Sustainable Mobility, the members of this task force are doing a regular survey on a quarterly base, and it is to investigate about sustainable topics which are connected with the European railway industry. These are only some questions, 3 to 5 questions, easy to answer in order to gain a picture of the importance of sustainability for the European railway sector. So you are kindly invited to participate in this survey as well. The link and all the links we are presenting you will find in the chat. And you can also use the chat for your questions to today's presenters. And for sure, you can directly contact ERCI via our email address, and you can find us on the web and on LinkedIn as well. That is my first part for today, and now we receive a short introduction of the purpose of this webinar and the agenda by my colleague Catherine Appleby from Rail Forum in the United Kingdom. Kat.
Thank you.
Maybe you can also introduce the slides here. Yeah.
Yes, I will do. Thanks, Lutz. We're delighted to be holding this webinar today. Hydrogen has been of interest to us, and we spent some time thinking about how we wanted to engage in discussion on this important topic. And so we settled on the format of today, which was really looking at trying to answer some of the questions about hydrogen and how it could work in rail. So I'm delighted to have so many on the call to join us. As Lutz has mentioned, we are a meta cluster. That's lots of different clusters across Europe. And one of the big things that ERCI is really all about is about connecting members from each cluster to other clusters where they've got topics of interest that they want to share and work together. So for this event particularly, we've introduced this opportunity for delegates to share in a business to business way, to share a little bit about what they're trying to do, particularly given the interest around this subject. So on screen, you will see a very short template. The bits in yellow are the bits you need to complete, but we've given some examples. And what we've suggested, if you complete them as Prosa have done, which you can see on the screen now, send it to Lutz, and we will share these contact details with those of you that want to have your details shared. So the action is, do complete the slide that's already been shared with you, send it back to Lutz, and we'll then share all of those slides with all of the delegates. So if there are people that you might want to connect with because you have a shared interest in hydrogen, why not just simply complete the slide? And the guys from Prosa have done it brilliantly. So thank you, Thilo and Martin, for doing that and being an exemplar for this B2B mechanism. So that's your action. Obviously, just checking on the agenda, then we've done a bit of an introduction to ERCI. We're going to kind of canter through the presentations onto the more meaty questions and answers. So we do want you to participate fully with this. Our presenters are excellent. We've done lots of technical tests and runs through, and we're really excited to share their presentations with you. Keep the questions coming in the chat, and we will get through them all during the course of the session. And then we'll wrap up at the end with a little bit more from Lutz to tell you what's coming up from ERCI cluster over coming months. So that leads me on to I think introducing our very first speaker and our expert host, because we wanted somebody that really knows the ins and outs of hydrogen. So we are delighted to have Helen Simpson with you. So let me introduce Helen. Helen started as a chartered engineer in the UK rail industry. She says 30 years ago, but that must be wrong. Surely it's only 10, and was previously the Innovation and Projects Director at Porterbrook. Now, for those that don't know the UK rail industry, Porterbrook is one of the companies that owns roughly 1/3 of the rolling stock, so quite an important organisation. She is widely recognised for her technical and commercial leadership on the rail vehicle innovation projects involving hydrogen technology, including delivering the Hydroflex train. And in 2023, she founded Inspired Consulting to provide strategic and technical engineering services to the rolling stock market. Now, she's also given me a fun fact, which I will share. Helen was nominated to attend the Royal Garden Party at Buckingham Palace via Network Rail for her impact at the forefront of several groundbreaking innovations in the rail industry. And I would also add that the Hydroflex train was also at COP25. Was that the right year, Helen? So it's really been presented at the highest level. So with that, Helen, the floor is yours.
Thanks, Kat. I'll just share my screen and hopefully we can see that. Hopefully that's working. Lovely.
Perfect. Thanks.
Right, thanks, Kat. So for those of you who don't know, thought I'd put a few pictures of some of the hydrogen projects I've been involved in to kind of set the scene and get us started today, thinking about hydrogen and rail. Kat mentioned the Hydroflex project. There's a picture of it on the bottom left there. And I was really lucky to have been leading the team that built, and got that into service. So it's now running on the main line in the UK, and my team did all of that design build and all the safety approvals testing to do that. I've also, since setting up Inspired Consulting, I've worked on the Vanguard Sustainable Transport Solutions project. There's a picture I took of their lovely Hydra shunter. That's a 60-year-old shunting locomotive that has been retrofitted with fuel cell hydrogen technology. So I gave project director and safety management support to the Vanguard team, and that's their hydrogen-powered shunter, which is now testing at the Severn Valley Railway in the UK. And the final example was a project we did last year, looking at can you transport the MEG-C containers by rail, and what safety management and safety approvals do you need to consider that? So I led an assessment of all the safety implications and then worked with some freight operators in the UK to go through all their safety case analysis to judge the difference between what the MEG-C containers had been built to road standards and what was needed for rail, providing a safety justification to show that that trial operation was possible. And that was working with Network Rail and Freightliner to do the first ever move of hydrogen in December 2025. So what I wanted to talk about was to kind of get some questions going a little bit, get you thinking a bit about the issues with hydrogen. So we've got quite a lot of routes in Europe that are electrified, but there are quite a number that are not electrified. So if we're looking at how to decarbonise the railway and we're moving towards net zero, and that is the objective, then we have to think, what are the options left to us? So we could do some more electrification. That's potentially zero emission if we get a green energy supply, but that does need a high capital investment. So really we ought to prioritise the routes that are higher speed or higher power demands for electrification. So that there's got to be electrification has got to be part of the answer here. We could do some more diesel trains. We've already got all the refuelling for infrastructure already existing. It's well understood. It doesn't meet the net zero objective, and we've got both local emissions challenges with NOx and particulates, and also global level challenges with climate change with CO2 emissions. So for many government policy and direction of where we want to go, and also the investment market is looking to move away from diesel products. So perhaps it's a solution in the short term, or a hybrid might be a solution in the short term, but it doesn't feel like that's going to give us the long-term solution. Next option is battery. Obviously, they're easy to maintain. Their range is increasing. The technology is getting better all the time, but they're not suited to longer routes or routes where power is limited. So you've got to have the recharge capability. Potentially at the end of a remote line might not be the best place to recharge the power on a battery train. So there's something here about both the energy supply and the rail network working together that are leading decision. Or hydrogen, which is, I guess, we've got some people interested in that topic today. So what are the challenges if we were to build hydrogen trains? So one of the things that's often quoted is the energy density. The hydrogen is a bulky, big gas. You need to compress it or cool it down to liquid hydrogen, very, very low temperatures to effectively transport large amounts of it. There are technical challenges. It's flammable at 4% concentration in air. It's odorless, colourless. It's susceptible to leaks, hydrogen embrittlement. It burns with an invisible flame in daylight. The fuel supply in the UK has been limited, so that's one of the challenges for the UK market. And fuel supply, we've got to think about where we're going to get this fuel from. So both the availability, the cost is often quoted. So the cost of, the kilogram per kilogram cost of hydrogen, and the logistics of getting the fuel to where it's needed. Then there are some safety and standards. I know there are some emerging standards, rail standards, European standards on fuel cells in rail vehicles and hydrogen fuel tanks. And there's been quite a bit of thinking and work doing that, but they're really developing with the technology. So we have to think carefully through the safety management approach. We have to think carefully about standards. And we've got a cost here that's changing from something we know. We've got diesel trains operating on the networks. and we're moving to something that's a bit unknown, and there is a cost in the moving from one technology type to the other. So those are some of the challenges. I'm sure a lot of you will have come across those, and some of you hopefully have overcome some of those. But those are some of the challenges that get talked about with hydrogen trains. But perhaps there's an opportunity gap if we think about that energy supply and the rail sector. So with the energy supply side, and we think about the grid, the national grid infrastructure, sometimes there are restrictions on where energy can be generated and where it is used. So geographic boundaries in the grid infrastructure. The batteries could provide a bit of a solution to that, but that's really restricted to short-term and more local geographic areas. It doesn't give you such a big energy vector. And the energy sector are really looking for technology like hydrogen that allows you to store it, use it and distribute it and use it elsewhere. But that is going to need transport logistics. We've got energy sector has got a drive from governments towards net zero and increasing renewable energy production. Energy buffers are going to be an integral part of that. If you think about solar and wind energy particularly, the amount that you can produce at different times in the day or different days in the year varies, and therefore we're going to have peaks and a varying supply. The energy sector is looking for something that can adjust that and cope with that buffer and those changes. Hydrogen production sites, so if we think about the people going into the hydrogen production market, they're looking for a steady guaranteed offtake and a mechanism to move large quantities of fuel to where their users are. So that's a little bit about the energy sector. And if we think about rail, rail has got some potential solutions to this. We've got a problem in rail that we don't know quite how to get to net zero. In the UK, we've set the 2050 target, with parts of the network heavily reliant on diesel, and electrification is quite constrained. There's no single solution for decarbonisation. In the UK, electrification, battery and hydrogen all have a role, and that mix will be different in different European countries, but I'm confident other countries will have the same balance and challenges to make. If we were to use hydrogen as fuel source for trains, we've got very repeatable duty cycles. Our trains run pretty much the same route all day, every day. They provide a steady offtake of 500 kilograms of hydrogen per day per train for about 20 years. Those numbers, those values of numbers are very interesting to people on the energy sector side, where they're trying to make hydrogen and long-term commitments in hydrogen production sites. So we are a potential user and a potential seed investment into some of those hydrogen production sites. We've also got an established freight network, major distribution hubs set up at all the ports. We've got the capability to move large quantities of bulk goods. That's what the railways are good at. And therefore, we're a solution to transporting hydrogen around. And we've already proven that we're really good at moving large quantities of dangerous cargo over distances. So I think there's a bit of an opportunity here between the energy sector and the rail sector. But what we've got to think about are some of the challenges that we need to overcome, and probably that's a joint energy and rail strategy with competing priorities for energy, both in terms of the technology and the investment, competing demands locally for energy, things like data centres, building developments are all asking for more energy demand, and as more and more transition to net zero, that is only going to increase. There's perhaps a lack of knowledge and lack of information about how to join these two sectors together. There's some competing opinions for the best solution for rail decarbonisation, and I think that's partly because there are different solutions in different geographic areas. And the systems are at capacity with huge infrastructure constraints, both rail networks and the energy sector networks. But there is a real missed opportunities for both energy sector and rail sector if we don't join these two things together and form a clear strategy. So what does this mean? So what do passengers want? Well, if we were to make a shift towards hydrogen trains, passengers don't want any surprises. They want their train to turn up, be reliable, have a nice interior, good facilities on board. They want to not be able to tell it's powered by hydrogen. What do train operators want? I think train operators are looking for hydrogen trains supporting the complete rail system transition to net zero. So they're looking for hydrogen trains to be part of that story. What do funders and governments want? A joint decarbonisation strategy joining energy, rail and probably some other sectors together so that forms one combined strategy. They want to prioritise transporting hydrogen fuel by rail because it's inherently safer than moving it by road, particularly as the volumes of hydrogen increase. What is the supply chain looking for? We want to know that rail is a really good seed investment in a hydrogen production site. So if we can join up a rail demand for hydrogen trains in one area with hydrogen production, we can make a really good economic case and a business case for the investment. The supply chain for the hydrogen wants to know that trains are a real reliable, predictable consumer of hydrogen. And rail offers that low carbon transporter of hydrogen, so we can move it, which should give the supply chain on the hydrogen production side lower costs for longer distances and being connected to ports and moving hydrogen about. So those were some of my thoughts. I hope that gives you some things that we're going to cover in today's session to help get you thinking of some really good questions to ask. We're going to, I think, have a look at some other presentations in a minute. We've got 3 more speakers who I know have got a really great conversation points to start, and we'll move on. We'll move on to that. I think. Stop sharing that one. Right. So our first speaker is Lorenzo Mirares Ferrer from SENA, who is a project director. Lorenzo has over 25 years of international experience in transport infrastructure, managing complex engineering projects. He's a chartered engineer and has worked across Europe and Asia on major railway programmes, planning, design and delivering large-scale mobility systems. Recently, though, he's been actively involved in innovative rail decarbonisation initiatives, including hydrogen-related programmes, and leading SENA's participation in international studies such as the FICO-FIO project in Brazil, and he's currently supporting the Impulso project in Spain, which is a collaborative initiative to develop hydrogen propulsion solutions for railway applications across the value chain. So I'm going to hand over to Lorenzo, and hopefully we'll have a very interesting presentation. Thank you.
Thank you so much. Morning, everyone. I'm Lorenzo Miralles, and I work for SENER. Through this presentation, we are approaching about how governments can be involved in this type of projects. We at SENER have participated in 2 relevant and different initiatives, the project FICO-FIOL in Brazil and the project Impulso in Spain. But let me do first a brief introduction about our organization. We are SENER Group. We are a Spanish company, a Spanish engineering and technology.
Lorenzo, will you share your screen?
Ah, sorry. I thought I was doing. Yes. Sorry. Let me do.
Perfect.
Okay. Apologies, everyone. So I was saying that, yes, we are a SENER Group. It's a Spanish engineering and technology company founded in 1956. We have presence in 5 continents with permanent offices, more than 18 permanent offices. We are right now around 4,500 people, and we like to say also that we have presence in 2 planets. We have projects in Earth, of course, but we have also devices in Mars with a rover Curiosity vehicle, and in the solar system with a solar orbiter. So our motto in the company is transform the world by challenging the boundaries of technology. And therefore, research, innovation, and exploring limits are in the core of the company. This is just a view of all the markets that we work for. I'm part of mobility division, but in this type of projects, there are a lot of synergies and collaboration between mobility and energy division, for example. Okay, we are going now to these 2 experiences. First one will be exploring hydrogen propulsion in the FICO fuel freight railway corridor in Brazil. This consultancy service was promoted by the World Bank. And the second is the Impulso project in Spain that is promoted by the government of Spain. A very, very high-level introduction of both projects in 2 slides. So the FICO fuel freight railway corridor, okay, in this study, we analyze the seating of hydrogen production plants, either adjacent to a railway infrastructure at maintenance depots, sidings, or dedicated locations, which require the provision of utilities such as power supply, water, road accesses, etc., or in nearby locations where the basic services, power, water, for example, are already in place, and just the transportation of the transportation to the refueling point has to be assured. High-level description of Impulso as well. This second project is called Impulso. The project receives fundings from the government of Spain through IDAE, that stands for Institute for Diversification and Energy Saving. This is the translation. And CENER is a key member of a consortium together with Talgo, a rolling stock manufacturer, Repsol, oil and gas company, Golendus, Ingiteam, Optimus. They are technology companies, and the institutional collaboration of ADIF. ADIF is the Spanish Railway Infrastructure Authority, so it's government. And this authority is fully committed and involved in this project. This project is still open and is expected to be finished next year. And we can say that for the Spanish government, hydrogen propulsion option is one of the key innovation vectors. So ADIF purpose, that means Spanish government purpose, is to find out whether hydrogen is a win option for some of their non-electrified lines, currently operated with diesel locomotives. There is this open discussion about which lines should be electrified or should be moved to hydrogen propulsion. I like to see that map that Helen showed in her presentation, showing the percentages of electrified lines and non-electrified lines. So, okay. In this work, in this project, our participation is focused on a comprehensive risk assessment of the whole system, from the production of the hydrogen to the operation, in a cost-benefit analysis that we are doing at this moment, and we have created a dedicated software for the digital management of the whole system, from the production to the operation and the refueling strategy. Okay, more details. We can say that most discussions start with about technology. So sometimes the question is, can hydrogen trains work? But the reality, thinking about governments, the reality is that the governments are asked a different question. They need to know whether hydrogen is the right investment for a specific corridor compared with other decarbonization options. That changes the entire assessment process. When evaluating hydrogen, governments are not analyzing a train, the technology of the train. They are analyzing an entire transport and energy system. Okay? I think it's good, these details of the FICO-fuel assessment that we did. In the FICO-fuel study, these were the 5 key questions that guided the assessment. For a better understanding, just to say that FICO-fuel is one of Brazil's most strategic freight railway projects. The corridor connects inland production areas with export gateways in the Atlantic coast and crosses regions with significant renewable energy resources. This made it an ideal case for assessing hydrogen propulsion. Important. Governments must also assess whether the regulatory framework is prepared for a large-scale hydrogen deployment. And I will put the focus many times in this concept. Hydrogen introduces new requirements related to safety, storage, transportation, emergency response, certifications, etc. And in many countries, we can say that regulatory readiness may become as important as technical readiness. A real challenge. So these 5 steps or key questions. Step 1, the starting point for the assessment is not hydrogen. The starting point is railway demand. Hydrogen consumption depends directly on traffic levels, longitudinal profile, elevations, loads, train frequency, future growth, etc., etc. But without a robust demand forecast, there is no meaningful business case. Step 2, one of the most important findings was that the energy ecosystem matters as much as the railway itself. The study evaluated several pathways, including hydrogen, ammonia, and bioethanol. The objective was not to select a fuel first, but to understand which ecosystem could support the corridor in the long term. We have seen an example in the previous slide, but a few years ago, maybe some years ago, the main question was whether hydrogen trains could actually operate in the real railway environment. But today, the question is increasingly being answered through projects, through evidences such as Talgo in Spain, the project Impulso, Alstom, the Coradia Island, the Hydroflex, of course, Stadler's, etc. And there are other examples. These projects demonstrate that the technology is progressing rapidly, quickly. As a result, the focus of governments is shifting from the vehicle feasibility towards infrastructure, supply chains, transport policies, and long-term economics. Step 3, infrastructure planning goes far beyond the location of refueling stations. It includes production, storage, distribution, and future expansion. And in the FICO-fuel study, the study identified a network of strategic refueling locations designed to support future growth while limiting infrastructure costs. Step 4, as we have said, technical feasibility alone is not enough. The key question is whether the economics work. Please bear in mind that the state of the art is changing every month, every year about the rolling stocks, batteries, cells, etc. But anyway, the study compared different fuel pathways and found significant differences in the long-term performance. We conclude that the most promising option combine renewable hydrogen production with renewable power purchase agreements. Perhaps The most surprising result was this. Brazil, I don't know if maybe you don't know, but Brazil is one of the strongest bioethanol industries in the world. Yet, the analysis showed that the renewable hydrogen supply through green PPAs offer the strongest long-term pathway to the corridor. And this was not an obvious conclusion when we started the study. So these lessons are not unique to Brazil. They can be applied to almost any freight railway corridor, considering hydrogen today. And the key is to evaluate the complete system rather than focusing on a single technology. In addition, and this is the step 5, one lesson that is often underestimated is the importance of regulation. Deploying hydrogen at scale may require updates to safety frameworks, permitting processes, hazardous materials regulations, emergency response procedures, and others. Technology can move faster than regulation, so governments need to prepare both in parallel, and that's not easy. And as a final reflection, hydrogen trains may be the most visible part of the system and the fancy ones, and we love them, but they are only one component. The real challenge is creating an ecosystem that combines transport, energy, infrastructure, and policy. Ultimately, the question is not whether hydrogen trains work. A successful deployment is not only about trains, energy, and infrastructure. It also requires governments to establish the regulatory conditions that allow hydrogen to be deployed safely and consistently across the network. Risk assessments are essential, of course, but they are only part of the solution. Long-term success requires an enabling policy and regulatory framework. The final question, is whether the corridor ecosystem works. And that's all. Thank you so much. And I'll let pass to the following.
Thank you, Lorenzo. That was excellent. Really thought-provoking. Some challenges there about getting the right question for government. I thought was really interesting. Okay, and next speaker is Guido Piccoli, who is a senior consultant and project developer with more than 30 years international experience in logistics, transport, mobility, energy transition, and territorial development. He's a recognised expert in design and implementation of innovative mobility solutions, transport policies, and has developed extensive expertise in specialist areas, including energy transition, renewable energy integration, and hydrogen ecosystems, working with the intersection of mobility, energy, and digital innovation. Guido has built a strong track record in European projects, having successfully been involved in numerous projects funded by Horizon Europe, Interreg, CEF, Intelligent Energy Europe, and other EU programmes. And I think Guido is going to talk to us about what infrastructure is required to deliver a viable hydrogen fleet, and can that be easily scaled? Thank you, Guido.
Thank you very much for having me here. Good morning, everybody. I think you see my screen and you hear me? Fine. So let's start from the words of Alan, obviously, which was introducing the ecosystem we are facing. And I would say I will not deliver much more than what presented before by Lorenzo, because unfortunately or fortunately, what is true is clear and simple. So we know exactly which are the triggers or the problem we are facing. But let's say I will give you also the vision we have from the experience in Lombardy, north of Italy, on the new project on hydrogen railway connection between Brescia and Iseo, Edolo. So from this perspective, actually, what works, what doesn't, and in which way we can support it is decarbonization in the lines which cannot be electrified. Just a few words also in my case about my company, Alot. We are a consulting company supporting public administration, operators, investors in a logic which is merging sustainable mobility, energy and digital transitions, turning mobility transition in actionable strategy, project investment, and as mentioned before, also the development and coordination of EU funded initiative. We are focused on the field of decarbonization in the railway sector, hydrogen mobility in general, and alternative fuel strategy. But what is really important for our side is the approach. We like to work on evidence-based analysis, stakeholder engagement, but also a really important point is the data-driven policy advisory, because sometimes we have a strategy or ideas which are not based on the scientific rigors, on numbers, and that is what also we try to underline in many contexts. So let's speak about the project, the specific project in Lombardy. Obviously, I'm looking at this experience as a benchmarking to learn, to have a lesson learned how to develop those projects, in which way we have barriers, or we can learn which aspect the factors has to be focused in advance or at least taken in consideration. H2 Iseo is the first Italian hydrogen railway project, introducing hydrogen powered trains and a refueling station as well on the line between Brescia and Edolo. So a regional railway, about 100 kilometer connection from the area of Brescia. Brescia is located between Milano and Verona. A really interesting area, a mountain area with a high demand of transportation because we have different poles of mountain for the tourism, but also people living in this area. We can speak about just the mountain area, about more than 200,000 people, so really a high demand for transportation. And the railway is a really important backbone for the public transport sector, connecting the main city, the center of Brescia, so with the peripheral areas. This railway has been historically really relevant, also for freight transport, and the investment decided by Ferrovie Nord, which is ancillary infrastructure manager Lombardy region, responsible for this event, was a key element for decarbonization. Since we have a line which has all the historical tunnels that cannot be modified unless a big investment in order to electrify, and therefore the challenge or the opportunity, let's say, of hydrogen was a key element for this transition. But as was mentioned before, sorry if I'm not saying something totally new, because obviously the case is similar from other previously presented. Again, the logic is how we start from a logic of rolling stock and how we link this aspect in a complex ecosystem. So looking at the other aspect. Therefore, this project was not just investing, obviously, on rolling stocks. So in these terms, 14 hydrogen trains replacing the existing diesel one. But first of all, also on the production of hydrogen, 3 hydrogen production sites in order to provide along the corridors the fuel for those trains. Plus the investment expected on 4 buses, hydrogen buses, to create or to increase the demand around this hydrogen valley, we can call it. Obviously the depot to maintain and to fill in Rovato all the trains, which are so peculiar and the only case in Italy, as I mentioned, this area that obviously need a dedicated depot. And this experience obviously teaches us, like was mentioned before, how we have to start, and we can consider the railway aspect as a starting point. But first of all, we have to plan, and that was Region Lombardy doing at that time, the complex ecosystem on a different way of production, fueling, and obviously storage concern. Another really important point about the history of this project is about the timing, in a way. We started with the first idea and political decision of project launch on the 2020, so we're speaking about already 6 years ago. Long terms of feasibility study and business case and funding approval for about another 2 years, and then the infrastructure development and train testing that actually were approved recently in 2026. for operation expected for 27. So it's clear how those aspects need also a public acceptance, because it was mentioned also by Ellen before, hydrogen is not such a nice beast, gas that people appreciate in general. Cannot see, cannot be smelled. If it's burning, you cannot perceive it. So it's really dangerous, even if it has a long historical scientific rules in the industry for the production and utilization of hydrogen. So it's not something new in terms of how to handle, but the point of diffused hydrogen in urban heating or for transportation and so on and so forth may have some concern from the public opinion. Therefore, we had also for Vaca Monica reality a lot of committee against the committee asking about information, to be informed, worrying about different aspects, and obviously a lot of commentators on the newspaper or any saying why you're wasting our money on hydrogen, why you can electrify the line, even if, as I mentioned before, it would be even much more expensive based on the logic of the tunnel infrastructure. So we had a lot of articles, a lot of committee, a lot of news against, in favor, not informed why you started for this, how you are going to produce this, where and which way. And then finally, if you look at the dates, recently, 1 month ago, we have the final authorization to start the service. That is real fresh news. But generally, as mentioned before, we have 4 main concerns about, tunnels, ventilation, hazard zones, the hydrogen in the railway station, which are obviously in the center of the cities, then which are the emergency procedures in case of accident while traveling, or for the cities and neighbor sites. In Italy, we have very worst case of bad events, on the railways, transportation of hazardous. Viareggio was a really dramatic case. So the sensibility of a public opinion about this fuel, it's really obviously high and has to be, comforted in a way that it's safe, is a sustainable solution also in this terms from a social point of view, as a conventional fuel. Then, sorry, but obviously it was mentioned already, the point about regulation, because regulation is much slower than technology, or lucky the other way. In the railway ecosystem, regulation quite stable, let's say, not to say conservative, because obviously we start from the safe certification, and now introducing hydrogen power rolling stock, it's creating also a challenge for the rail world in order to approve the utilization, as we mentioned, just recently authorized for this operational aspect. Then we have the industrial safety for storage, for compression, for production of the facilities, the energy rule itself about the pipeline, the distribution of hydrogen, green or any other, obviously still hydrogen, and all the environmental permitting for the land use planning and station adaptation. So, because those are existing stations that we are, let's say, retrofitting, reorganizing in order to use hydrogen. So in general, we saw how the simultaneous authorization was a challenge in order to provide all the features in different domains, and how permitting was really one of the key drivers for the delays of this implementation. So lesson learned definitely is not a challenge of technology, but we have to consider upon the authorization procedure in these terms. Then from this, let's say from the economical scale, so the general ecosystem of hydrogen. We are always aiming for hydrogen valley, where hydrogen valley simply means a microgrid where I have the energy to produce hydrogen, I use the hydrogen, I have a lot of client for the hydrogen production in order to scale down the price, to scale up the efficiency, the sustainability, economical sustainability. So we have to consider that the railway cannot justify hydrogen infrastructure. No way. It can be the starting point, it can be the anchor customer, but we have to create an ecosystem around, because the uncertainty of the cost, both of the capex, so the investment in electrolyzer on storage system and the other, which may decrease if we diffuse more, is an unpredictable element when we have such a long planning project. the same as the OPEX aspect, so the production of hydrogen. So to reduce this unpredictability, to reduce the uncertainty of those investments, definitely it's important or can be solved in a way comparing with demand options. So including alternative demand options can be really a great importance in the planning of those projects, which I mean, behind the railway aspect itself. That was also a challenge, as I mentioned before, including hydrogen buses, including other uses of hydrogen on the territorial ecosystem. I'm moving slowly or fastly to the conclusion, but just to sum up some main aspects. So what we really believe from this experience in Lombardy is that the real challenge, the real test is the scaling, not the feasibility. Technically, we know how to handle hydrogen, we know how to develop the production, the railway system, and so on and so forth. The problem is how can we create a pilot, an example that can be replicable, feasible also in other locations, transferable in a way to learn what can be the lesson learned too. First of all, stable supply. This is really the biggest challenge at the beginning, because when we speak about electricity or fuel, diesel, it's a day-by-day business. We have a fuel station, we have a grid to provide the electricity, so it's nothing to invent. In the case of hydrogen, we have a big challenge. Hydrogen is not available in terms of green hydrogen. So one proposal is obviously to decoupling green hydrogen and hydrogen use. So let's start to use hydrogen. Doesn't matter which hydrogen, because then at least we can create a demand, precondition for green hydrogen demand. But this is really important, how to work in order to create a stable supply of hydrogen, and green hydrogen particularly as the future aim. Then the predictable cost. I was mentioning before, CapEx and OpEx are really two open points. We have a lot of providers proposing contract, service contract, supply contract for hydrogen, but the price is not yet predictable. So we can agree on the quantity in case then from the investment, but from the economical change, the development, the scale of the cost, definitely we have not yet a clear picture of those costs, and that is again making uncertainty in the different project and acceptance on different players and decision makers. Sorry. Then regulation, as I mentioned before, authorization and the time that those regulation adaptation needs for the development of those projects, and then the political continuity. When we're speaking about public transport, we are speaking about public investment, local public transport particularly. So if we don't have this continuity, it's hard to invest in a project like the example of a Valcamonica project lasting for 7 years, because then we have a lot of new people coming. They may decide to change the investment, they see different priorities. That is really a big stopper for the planning, because we're talking about over 390 million investment of total investment, a number of trains that technologically needs really a kind of timing for this. So the problem of replicability in different regions, particularly the one having low funds or low public commitment, it's really hard, and the escalation of the cost and timing for this debate for the permission and regulation may increase really a lot of time, and therefore reduce the happiness for this novelty on the market of transportation. So what we learned from Valcamonica experience that teaches us definitely hydrogen train can be integrated in the railway system. That's no question about. Obviously, we have other examples around Europe. Rail can be, as I mentioned before, an anchor customer for infrastructure investments in the hydrogen. That is really important, because then we have to consider one of the bricks for other investment on hydrogen, the utilization, the production. And hydrogen obviously can connect mobility, energy, industrial policy. It's really important also to have a kind of lobbying with other potential users, particularly the industry, which are really the highest potential user demand for hydrogen production. On the other side, what's still open? We have not continuity stable supply of green hydrogen, and particularly the cost is not yet competitive, logically, not stable, not big scale, therefore higher price. We have struggled on the timing, on the implementation timelines, and therefore how to reduce, I explained already before, but it's still, multi-stakeholder involvement creating problems because we have not the same priorities. How this model can be sustainable everywhere and not only in a specific context, how to diffuse this kind of logic in the planning, and in general, how we can compare the solution of hydrogen to electrification and battery alternatives, particularly for a line, I would say short line, 100 kilometers, when we have a hybrid diesel electric or fuel electric trains, fuel battery trains, which may cover already this distance, maybe with less problem and less investment. So, but in general, the final statement from my side is how can we scale the project? So the problem is not to run the train, but really to scale up this project in other area and apply in a continuous way. Thank you very much from my side about, the experience I presented from Lombard division.
Thank you, Guido. That was excellent. I really enjoyed hearing all about those scalability challenges. Were really fascinating. Okay, our third speaker is Antonio Hilliard, who is the president of CITAV and has been with the company for 5 years, having got a master's degree in mechanical engineering, and he's the third generation majority shareholder, as well as the head of research and development at CITAV. And Antonio is going to be talking about why we should think about the conversion of equipment to hydrogen as the first option for rail equipment, and specifically looking at some hydrogen in shunting environments.
We cannot hear you at the moment. Maybe you have to unmute. Antonio?
I'm sorry, can you hear me?
Yes, better.
Okay.
Please proceed.
Can you see also the presentation?
Yes.
Well, okay.
All is good.
Okay, thank you very much. Let me firstly briefly introduce CITAV company. CITAV is an Italian family-owned company that works on railway market with production sites in Italy and with operation of maintenance around Europe and in the US. The activities of our industrial group are linked to all the phase of rolling stock life, from the design to maintenance through construction, modernization, revamping, and so on. Going on and trying to explain our idea of hydrogen solution for shunting, especially about revamping of existing loco. I would like, first of all, to explain why revamping and reconstruction can be a good solution for this type of product. Shunting activities must be cheap, and so the rolling stock used for these activities has to be as cheap as possible, and reusing a locomotive already existing can be a good way to save money. And on the other hand, shunting locomotives are quite standard in dimension and shapes, so it's easy to find a design and a solution to standardize the type of refurbishment and maintaining just the frame and the bogie of the old loco. So when we speak of refurbishment, we don't mean just an upgrade, but we mean a complete reconstruction of the loco. Just to be clear, we take the old loco, then we dismount everything on it. We maintain just the frame, the bogie, and then on this frame we go on and construct and build the new loco with new systems and new technology, and so that the loco is practically new, and the final result is of our experience on hydrogen is this. We developed a prototype, a running prototype, able to face with the regulation request by Italian railway system. We present our prototype, our solution last year, and in this case is strictly based on a revamping, as you can see, and the solution is an hybrid solution that use hydrogen and battery. Hydrogen is used thanks to fuel cell power system to bring the energy to the whole locomotive, and the batteries are used to face the peak of power and the braking phase, so that we can recharge batteries while the loco is slowing down. We were focused also on the type of storage to use. We decided to use an innovative system based on metal hydrides, and this type of storage allows to maintain the pressure as low as possible. We are speaking about 35 bar of pressure inside the storage, and this configuration is able to guarantee the maximum efficiency working condition, and at the same time the minimum fuel consumption. This solution is a specific solution for shunting activities, because we think that this type of activities is the perfect one to start to introduce hydrogen in a railway. This is because shunting yards and harbors are typically not electrified, because you have cranes that work around, and it's not possible to have the metal wire of catenary on your head. So the loco has to be self-propelled, and apart from the standard and traditional solution based on a diesel engine, we think that an hybrid solution based on hydrogen fuel cell system and battery can be the best solution to bring the ecological transition in this place, but also to develop a new energy carrier that can be an alternative to the traditional one, especially in this period in which we can see some problems linked to the supply chain of traditional energy carrier has diesel and petrol, linked also to geopolitical problems. So going on, speaking about why shunting activities are for us the best starting point. The shunting activities are typically characterized by high peak of power to push and pull the wagons, but at the same time a low energy consumption, because the running time is not so. There's not a huge amount of time on speed a high speed. We have a maximum of 30 kilometers per hour. And this mission profile allows the hybrid solution to use, as I said, the batteries to face the peak of power, and at the same time the fuel cell system to charge the batteries and provide the energy that the loco needs for the shift. And shunting activities are done in confined areas, typically. At the same time, in urbanized context, typically harbor are close to big city, but at the same time, they are closed areas, and harbors are strategic hubs where trains, ships, and trucks meet. So is a good place to start to introduce a new energy carrier like hydrogen, and using low pressure for the storage. We can do the refill of loco just with a truck that brings the gas and at 200 bar. And in Italy, this is allowed by the regulation. So every day in Italy, there are trucks that brings hydrogen at 200 bars. So can be a good solution and easy and safer to start to use hydrogen. And as you can see, in Europe, there's an expectation for an increase in the use of hydrogen from Antwerp in the north of Europe to Livorno in Italy, so in the southern part of Europe. This trend is increasing. So considering these two aspects about the environment in which shunting activities are done and the type of rolling stock used there, we believe that shunting loco powered with hydrogen can really be the first step to really introduce hydrogen as an alternative solution to more traditional energy carriers. So, thank you very much. I'm here for any question.
Thank you, Antonio. That's excellent. Right. Well, I think there's going to be a lot of questions. I can see there's loads going on in the chat. So if you have got other questions, please do add those in. Lutz, I think, shall we start with the questions in the chat, or do you want to start with the questions?
I already summarized all the questions coming from the chat to slides, and at the moment I have 4 slides, and
we're going to be busy then, aren't we? Okay, so I'll try and group these together because we've got a kind of like, I think we've got people on here that could talk all day about this topic, so that's great. But we'll try and manage the time a little bit. So shall I start going through these questions for you?
Yes.
Okay, so one I get to kick off with, is it the increasing cost for diesel fuel a big enough driver for national networks to seriously consider hydrogen? Well, one of the things we've heard consistently in all the presentations today is that it's a hydrogen economy, there's a hydrogen valley, we need lots of different sectors to come together. And whilst diesel cost increasing and hydrogen fuel costs reducing will help the business case, you need a lot of other things to come together. So I think that's kind of been talked about today. Right, Lorenzo, from your experience, what are the key governments use to assess whether hydrogen rail solutions are viable for freight corridors?
Okay. Well, I've explained in the presentation, I think so, but yes, a government assess the feasibility of a rail corridor by looking not only about a specific technology, So they are looking in the complete system, okay? And we can summarize the key criteria in freight demand and traffic forecast, feasibility of hydrogen supply, the required infrastructure, long-term economic performance, and the alignment, yes, of course, and the alignment with energy and regulatory policy, and everything comparing hydrogen with other alternative decarbonization options, of course. Okay.
Yeah, good. And the second question there, perhaps if you could expand a bit on the opportunities for governments. Presumably, because we talked a few challenges in the presentations, but there's some opportunity here, isn't there? What do you think the government view of the opportunities for hydrogen?
Well, yeah, first, the challenge, of course, is the complexity, is the complexity of developing a full hydrogen ecosystem. And maybe the key opportunity lies where hydrogen can enable decarbonization while also supporting energy transition, regional development, and industrial strategy. I think, I don't know if Guido said something similar. And in terms of cost-benefit analysis, of course, the social and environmental components have a strong presence in this type of cost-benefit analysis, and it's clear that hydrogen can help to a more sustainable transport system. Okay.
Yeah, thank you. Okay, so a couple now for Guido. So when people think about hydrogen in rail, what do you think the biggest challenge is? The trains, the infrastructure, the economics, or I have a suspicion you might say the regulation when answering this question, given what you talked about?
Well, personally, maybe also picking one of the questions I see in the chat. I will start from the concept of hard to abate, because the other way is maybe we're turning around the problem. So first point, speaking about hydrogen, we have to understand when and where we need to use hydrogen, not to be Taliban in a way that we won't have hydrogen, doesn't matter. The point of hydrogen is for the missions, for the place where hard to abate cannot be, electricity, batteries cannot be the solution. Otherwise, we are wasting time, I would say. So starting from this point, hard to abate is not a standard concept because it can be changed in the future based on the scale up of the cost, capex, opex, and so on and so forth, and the diffusion of the demand. So this is the main starting point to understand when we need to use this. And then from this, we have the right decision makers, we have the right components to diffuse hydrogen in the railway system when it's really needed, because otherwise it's better to have electricity directly, electrify lines, or electric battery trains. The example of the previous one on the shunting of the terminal, it was emblematic. We don't have electrification because we cannot use there because of crane problems in the terminal and so on far. Therefore, what to use it? And that is really good for the demand of that power, for the autonomy, and so on and so forth, like you described, and it's really feasible also in feasibility. So to sum up, the point is not about the technology, it's about the context, the ecosystem, and therefore in which way we have first a regulation enabling what is needed from the European Commission down in terms of strategy, FED and other. And secondly, the acceptance of the economical players in order to invest in the right sector in the right moment to scale up and to create a community for the usage of hydrogen. Also, what I said before is not to be, orthodox in the way that must be green hydrogen if green hydrogen is not available. Maybe start with hydrogen, because it's really important to create a demand in parallel with the diffusion of renewable sources for the production of green hydrogen. So sorry for the comprehensive answer, but it's much more complex and we have to be really pragmatic in the maturity of the hard to abate.
Yeah. Okay, and then following on from that, if a region decided to replace a fleet of diesel trains with hydrogen trains, what do you think would take longer, the trains or the hydrogen system around it? I guess you talked a little bit about decoupling the production and having not necessarily
Yeah.
having green hydrogen.
Yeah,
But,
indeed. The problem is also the scaling up of the transferability of the example, and therefore for the market, the producers of hydrogen train, how much or how many trains we can have based on the different standard and different ecosystems. For long distance train, we need more wagons and therefore which kind of power, traction and autonomy and so on. For shorter one, are we challenging with the battery trains and therefore do we profile something different? So I don't know how the market of the producer is ready to have tailor-made solutions, for each railway path, considering, like you described, the one not electrified. So is a niche market is something that we expect a large diffusion of railway stocks, locomotive and the rest. That is the biggest problem for me, I would say, for the cost, the capex in terms of railway stock in these terms. So this is one of the points that we started to understand if it's feasible in these terms, the replication of those pilots, having really a tailor-made solution that we have to apply everywhere for every case.
Some thought-provoking things there. Okay, so Antonio, there's a couple of questions here for you. Is hydrogen just a synonym for clean, renewable energy?
For sure, for the loco that use hydrogen, the emission will drop to zero. But as Guido was saying, it depends by all the environment and ecosystem around and linked to that use of hydrogen. Because if I use gas or traditional fuels to produce hydrogen, I just move the problem to another place. So it depends by the environment, the ecosystem around.
Yeah, it follows nicely to the next question there about people always think about hydrogen, don't they, as a highly volatile explosive gas. Do you think it's safe to store and use refueling your shunting locomotives in urban areas?
The use of shunting locomotives in harbors and shunting yards means that you are in urbanized area, but at the same time you are in a closed area. So you are typically far from buildings or activities not strictly linked to the harbor or the shunting yard. And on the other hand, the hydrogen is a gas that is lighter than air, so typically flows away. And it's better than GPL that stay on the ground. So yeah, is an explosive gas, but we know other gas potential explosive and dangerous, and we use that every day. So I think we have just to learn how to face with this new technology. But I don't see a specific big problem about hydrogen gas.
Also my experience as well, Antonio. There's just you have to think carefully about it and learn how to be around it. Yeah, exactly. Okay, so some more questions. Do you think hydrogen gives countries energy independency? What or which components or anything in the system can prevent this, such as rare earth metals for very critical technology? So one of the things that's often talked about with the hydrogen energy sector is the giving a country energy security. So if you're making more renewables and using that to make hydrogen, you're a little bit more secure in your energy supply as well. But the second part of that question is the rare earth metals. There are a few in fuel cells, but most hydrogen trains also have a battery, which is where you'll see more of the rare earth metals being used, and that's a far bigger problem than just hydrogen in rail. That's how is the supply of rare earth metals being used in battery technology, and what we're using batteries for, and our energy thing. So I'm going to slightly duck that question because it's a little bit more complicated. I think we might need another 2 hours to kind of explore that, but it's an excellent point made. Do we see a trend to reduce the cost of supplying green hydrogen, and which countries are capable today? I might ask some of my fellow presenters to help with that, because I know some of the countries we've been talking about in the projects have really made some good progress. The production in the UK is improving, and green hydrogen costs are dropping considerably in the UK, but I don't know whether any of the other presenters wanted to talk about their countries and the different relative costs of green hydrogen. Are you seeing a trend in reduction? Lorenzo or
Yeah,
Guido?
okay. I would like to say here something, because in the Project Impulso we are exploring. Well, the Project Impulso we are testing. We are doing a real testing with a Talgo locomotive, the technical car, and we are designing and installing a small hydrogen production plant and a refueling point. Okay, because in the balance, if we have to buy hydrogen to an oil and gas company, and we have to transport that hydrogen to the refueling points that we need, we have two options. If we do the transport with trucks, there are emissions. There are CO2 emissions and CO and others. If we are doing with pipelines, it's very expensive. So we are testing, and this will be a real test, to create a dedicated hydrogen production plant just for a section of the railway, a line more than 200 kilometers in Spain. In this case, this hydrogen plant will be owned by the Spanish Railway Authority, and well, this is a test at this moment. We are doing the work. So at the end, I think everybody agrees that the maturity of the hydrogen market is not ready. So we don't have an stability in the prices, and we are looking for these other options, is to create our own hydrogen for our specific line. So at the end of one of the one of the ends of the line. So this is how we are exploring and managing. Sorry.
Lutz, you're not on mute.
Yeah. There was a person. Sorry for that.
Okay. Okay.
Okay, thanks, Lorenzo. Yeah, I think the trend is lowering of prices as more bigger sites come on production, but some interesting cases to make on a particular railway line as to whether that's locally produced and how you're going to transport it, which I think is, are we using rail enough as well to transport hydrogen? Comes into that, doesn't it? There's quite a complicated question here about somebody's been to talk to London Bus about how they bring engineers from Switzerland to maintain specialised parts. So there is a kind of cost in training people with hydrogen. Antonio, you mentioned it, didn't you, about having to be aware of how to behave around hydrogen. So there's a lot more training and knowledge to understand how to do that. And it's probably fair to say we haven't quite got the full supply chain flowing through for overhauling of fuel cells and repairs and things yet, because it's all still relatively new. But that should come as larger scale deployments happen. So yeah, it's a really good question. It is a bit chicken and egg with which one do you do first, but you kind of have to start somewhere. And I think both Lorenzo and Guido talked about the whole hydrogen valley, the hydrogen economy in an area being important as well. Okay, so we got a couple of questions now for Lorenzo. Is the technology ready and available, but is it competitive to operate against other legacy equipment and technology? And do the suppliers help with that?
Well, in the two studies that we have worked for the FICO fuel, as I said, it was a surprise that Brazil is the second. I think they have the second position in the world in production of bioethanol, and we thought, okay, we can produce by cracking bioethanol, we can produce the hydrogen, but the technology is not enough mature at this moment. Although the state of the art in the last 2-3 years maybe has changed. Okay, and that was a specific project, a very specific project, because almost 2,000 kilometers for a freight railway, very slow speeds, and slow speeds. So every 8 hours, a change of the driver of the train, so we have time for refueling, and hydrogen work installing, I think, in 6 points along all the route, installing hydrogen, dedicated hydrogen production facilities. Okay, and that was competitive in the cost-benefit analysis, considering always the social and environmental benefits. It's not a question if we forget social and environmental benefits, it's not competitive, to be honest. Okay, because at this moment, the technology I'm not speaking about the technology about rolling stock, cells, battery, etc., because I'm not an expert on that. But I would say that the results are good enough at this moment, and it's a question of the governments have to push the policies, and maybe in Europe is with a common policy. Of course, we need that, and I would say yes, it is competitive. It depends, of course, on the corridor, and I think it was a very good point from Guido. We can, maybe it's not a question to split this solution to all the non-electrified lines at this moment, but for some of them, maybe yes, it is competitive. Some of them, okay.
And thinking about the project in Brazil, was there one factor that drove the decision that could somewhere else, or do you think it's more to do with that particular route, or what can other countries learn from that project?
Well, at this moment, the Pico Fuel Corridor, what the World Bank tried to promote is to support Brazil's federal government to develop this technology. This corridor is open to the market. They are looking for private funding to develop this corridor. So at this moment, I cannot assure that this will be the final solution, because my last news was that some Chinese company was interested, providing their own rolling stock. So I don't know, to be honest. Common lessons learned. Maybe okay, we need to study each one. We need to study each one of the corridors. We cannot, as I said, spread the same solution to all the network at this moment. At this moment, we don't have a mature hydrogen market. So I think in the two projects, the solution is to create our specific hydrogen production plants, and this is where this is part of the capex, of course, but it managed better the opex. So for Impulso, we are in the stage of the cost benefit analysis. We don't have results at this moment. Next year we'll have, and I don't have more information to share.
I think there's a direct hand raise from Guido, maybe responding to that aspect.
Yeah, because I think what Lorenzo said is really important. Maybe, I mean, it's the same logic I explained before about scalability, replicability. The problem is that on one side, we have a single case, a pilot test, proving something. in our countries, like my example, the one in Spain, and so on and so forth. Then we see that those are cases of the proof of concept still, I would say, where we can take and get some metrics, but then we need at national level at least a common vision, a decision concerning. So we have single pilots, then we need whether for a national level of planning public transport, local public transportation or longer distance, a decision concerning the not electrified lines to move towards hydrogen as the entire market. The kind of decision where may create a demand of hydrogen, because then the producer, the manufacturer, they say, okay, I see the option to produce a certain quantity, both equipment-wise, technological-wise, and hydrogen-wise. This is really important point. If we have at European level or at national level this kind of decision, then we can open the market, because that is coupling with the other issue that is about industrial decarbonization. If we can place this kind of two decision, it's policy making more than investment making, then we can open the market, because then we couple the demand on industry on the location of the railway station, fuel station for the railways. Then we create the logic, the seeds for the hydrogen valleys. Then we create the condition for market to invest even more from the piloting phase to the scaled phase where the cost will be reduced, and then we can support the diffusion. This is the point. We cannot work singularly bottom up to produce the metrics. Only metrics are not enough. Now we have to lobby on the national level for general public transport, for energy transition, working in order to this strategy to create the market conditions for both aspects. That's really, I think, it's the point to move forward.
Good point about the lobbying, Guido. Thank you. Okay, I think this next question is quite a long question here. This is a really valid point this person is making about the space and the energy efficiency of fuel cell and battery technology. Most hydrogen vehicles are a blend of fuel cell output and battery output. Some use the fuel cells to charge the battery and increase range. So that's a very much kind of the laws of physics of the geography of the route and the power output. But that's a point well made about the passengers also care about the space and the weight of the equipment that you're installing. So that's a definite heated debate, I'm sure will go on, but it becomes very route specific, the correct decision on the power output. So that's the answer there. Guido, there's one here for you about, do you know if the EN standard is going to evolve under the ERA to support hydrogen technology in rail? Have you got, I think might be on mute.
Sorry, I have no direct knowledge on this field. I have to say we didn't went in contact with the ERA concerning. I'm sorry.
I think they're continually updating the standards on those. So
yeah, for sure. Yeah, but I have no updating.
No, okay, that's fine. That's fine. Right, another question here about hydrogen in the UK. Do manufacturers have too high a focus on refurbishment of hydrogen rather than committing to develop a new fleet? It might be companies like Porterbrook wanting to prove a viable product before huge investment, but few operators might want to commit to an old platform with obvious compromises and unknown live reliability to provide a service trial without knowing the benefits. That is a really valid point. This is a really complicated picture in the UK. One of the reasons that Porterbrook chose to do the Hydroflex project was to increase their corporate knowledge and understanding of hydrogen so that they might fund some future vehicles, being an asset owner and a finance company. So that's why one of the main reasons why they did that project was to increase their knowledge. It's a chicken and egg question. This is that, do operators need to see a hydrogen train, just trust in the technology before making the commitment on a big fleet, or do we go for the big fleet and do the kind of analysis that Guido and Lorenzo were talking about a whole hydrogen system in an area and it's part of something much bigger? So that I don't think the UK has made those kind of advanced level decisions yet. There's some of the devolved governments that are thinking about it, but we are behind some of the other projects that we've heard about today, I think.
Yeah. Are you ready for some more questions?
Let's do some more questions, Liz. Guido. In the UK, several hydrogen manufacturers do not progress without the rail sector committing as an anchor for almost the entire production. Is that the case with other industries, and that we might need to increase hydrogen use to reduce the responsibility of rail being the anchor for new developments? It's a good question.
Well, again, from my experience in hydrogen diffusion in general terms, we have three sectors, you know already. I mean, for heating system at urban level, mixing with other fossil fuel solutions, mobility and industrial decarbonization, beside other, mix that hydrogen can be used for ammonia or other industrial usage, let's say. So for me, the key player, the first one, I mean, the biggest sector is the industrial decarbonization. The one every nation should aim at as a first target for the demand of hydrogen. So we need this kind of policy supporting industrial decarbonization to have the biggest user of hydrogen in place. Based on this, then we can open the point about mobility as a second pillar, let's say, or heating, urban heating system. That is, for me, a strategical point of decision. Otherwise, mobility itself it's too scattered, or we have too many users, but we don't scale the quantity of production for pure mobility usage. So we need to start from this sector, industrial decarbonization, and then cluster together other usage in the logic of hydrogen valley, having there also the fuel station, refuel station for buses, for trains, for long, high demand energy usage and mobility. This is the way strategically and territorial development we need to work, whatever at regional urban area or at national level, like I mentioned before. Then we will have the field for technological provider, for manufacturer, for producer of hydrogen to see the condition to have a good market concerning whatever import or local production. That's also a point about the question about national resilience from hydrogen. I don't want to open this question as well, but it's also a really tricky, interesting point from the contingency we are facing at political level at this moment.
Yeah, sort of topical point, that one, isn't it?
Yeah.
Some technical questions now for Antonio about your metal hydride cylinders. So there's a couple here. We'll try and group together. So how many kilograms of hydrogen are stored in the metal hydride cylinders? And did you find any disadvantages of using the metal hydride?
It depends. I start with the first question. It depends. The concentration of the density of hydrogen in metal hydrides is slightly better than the high pressure solution. And how much hydrogen? It depends on what you need to do with the loco. We designed a modular solution because for shunting, we think it is not useful to have a really big storage that brings costs and a more difficult system. The prototype we've done has 30 kilometers of hydrogen, while the loco we have won a tender to supply some hydrogen loco, and for that loco we are speaking about 60 kilograms of hydrogen. But it depends on the needs of the customer. And about the disadvantages, metal hydrides are heavier than high pressure solution, but this can be a problem on a passenger train. We are speaking about a locomotive, so the locomotive has to have a specific weight to push and pull wagons. We are speaking about 80 tons. So in any case, we have to reach that weight. And so the weight, the heavier situation that we have with metal hydrides is not a problem for our situation. Probably there can be some problems, let me say, but it's not a problem in managing the power inside the metal hydrides. But after a risk analysis, we found out that is in any case safer than the high pressure solution. So this can be the two disadvantages.
Thanks, Antonio. Guido, there was a comment about there's so much, we enjoyed that talking about the public engagement side. It's quite interesting to hear about that. In that process, is that public engagement best led by the Hydrogen Valley Consortium, by the local government, by the sort of lead supplier? What do you think would work best for a future project?
For me, definitely from the local authorities, because they are the most closer to the citizens' understanding. I would say that if we speak about pure technology, then it can be quite complex to understand. If you move first from the benefit deriving, for the understanding of the people, for instance, we can provide more environmental sustainable public transport. We can have a cheaper solution, even if cheaper is not really the keyword for hydrogen at this stage, but in future, obviously, we can make it more resilient, more sustainable, and so on and so far. Then, obviously, the citizen may understand, first of all, why we are doing, and then gradually ensure the technical aspect, which sometimes has a technical word or something complex. So I would rather move from the local authority, the association, the mobility operators with the citizen, with the user, with the clients, explaining what we are doing in these terms. And then comforted for the reason, moving in case with a clear and open and honest, if you want, description of the technical aspect. But I will not start from the university technological provider, these kind of people, sorry, not against them, but just to say that sometimes in terms of communication, they may not comfort starting from the needs and the benefit, but they start from technical aspect that may be not so directly understood. In general terms, I would say. That was done also in Lombardy in a way.
Yeah, good. And then we've got a question here. I don't know who's best to answer this one, Guido, but perhaps we can have a discussion about how might the use of hydrogen vehicles and the costs associated with that be offset compared to traditional fuels to allow a commercial contractual comparison within tenders. Now, that's quite a tricky question, isn't it? Because often the cost is higher for a hydrogen system because we've got all those changes we've talked about in the infrastructure and things around it. So I'm not sure whether it is a direct comparison. Guido, do you have any thoughts on that?
Well, I will move back to the concept of hard to abate again and again, because this is a basic element. We will always use an alternative fuel where it's more sustainable, where we have more energy encapsulated in the same quantity, volume, or weight. Why we were successful in diesel engine or benzene engine instead of electric vehicle, even if electric engine was invented before, because in our tank we have more energy than any other way concentrated in weight or volume. With hydrogen, we need big volume. With electricity, with the battery, big, larger amount of weight, kilos. So that is the reason why. So if we move from this and we explain why we have something else, or the technology will solve the problems, then we understand why to use an alternative fuel solution. That is really pragmatic, I would say. And then I have to explain because it's no energy from the pure energy efficiency point of view. Hydrogen is not the solution. Electricity is the best one. I produce electricity, I use electricity in my engine. If I move through a middle vector like hydrogen, with electricity, I produce hydrogen, then I transform hydrogen in electricity to move the engine, because at the end, hydrogen train fuel cell is an electric train, so that is not logical, not efficient in terms. So we have to explain why hard to abate is a point, and then based on this, describe why hydrogen need to be one part of the solution of energy transition, to use only renewable sources, and therefore not to pollute, not to create additional CO2 in the atmosphere, and so on and so forth. Those are the basic elements to explain the additional cost for these terms, the social impact deriving, the environmental impact deriving in an overall concept. Otherwise, we are missing one point, and we're just looking at the cost or the risk, not having the overall picture, or even for the user acceptance.
Yeah, I guess it's back to Lorenzo's point about the business case and what are the governments really asking, isn't it? Rather than just running a competitive tender process. Okay, and I think we've got one final question, Guido, about has the introduction of hydrogen trains on the Italian rail network increased risk due to working and driving in tunnels? I did wonder whether we'd have a tunnels question today, so yeah, thank you whoever sent that one.
Well, if I look at the other case, we have 5 cases of hydrogen project in Italy. 3 are small gauge in Sardinia, Calabria, if I'm not wrong, in center of Italy. And then we have 1 and 3 prototype antis, particularly in Sardinia, quite advanced. Otherwise, we have 2 in Puglia and another one in Puglia already in realization, plus the one I described before. I think among them, the most risky is the one in Lombardy, because we are in mountain area, while the other, also the one in Lazio, Umbria and Abruzzo, is a bit more. But I would say that mainly we have a hydrogen solution in area with less risk of tunnel, as my general perception, but I should analyze all the 5 cases to give more details. I don't see it as a main problem, absolutely. Because the safety condition can also provide.
You have to go through a common safety method for the introduction.
Absolutely,
for your hydrogen trains anyway. So that will include all the risks of working in tunnels anyway, won't it? Good. Okay, thank you ever so much to all our speakers. I think we're almost towards the end, are we, Lutz? And I know you wanted to just talk a little bit about what's coming up next. But are there any final questions that anybody wanted to raise? We're all good. Okay, well, just thank you ever so much to everybody. And I'll hand back to Lutz for the last little bit.
Yeah, thank you, Helen. Thank you, Kat. Thank you to all of the presenters of today, and thank you for all of your questions. And we as ERCI have a little demand to you, a little question. We kindly ask you to fill in our short questionnaire. It takes you 2 minutes to answer something about the quality of the presentations, and what is the most important is to learn what topics are you interested in for future ERCI webinars, or are you ready to present your innovative solution during one of our next ERCI webinars? So don't be shy and indicate your demands or your willingness to present. You will find the link and the following links also in the chat. Kat is so kind to put them all into the chat. It will be a recording of this webinar, and it will be available in a few days at the YouTube channel of ERCI. And yeah, coming to the next webinar, long summer break we are facing with, but on the 9th of September, before the InnoTransfer, we have another webinar on the topic of AI and video analytics for smarter rail maintenance. Registration is already possible. We have about 25 at the moment so far, but it could be more. Some update information, what we are normally doing to inform you about current projects, about funding opportunities, about upcoming events. I will take this opportunity to give you some short updates. There is a collaboration between ERCI and the European Lightweight Clusters Alliance, and we are planning to perform a joint hack and match event. The title is Design the Future, Hack the Waste, the Full Lifecycle Mobility Challenge. The five challenges I want to introduce you quickly. Now the call for solution is running, and on the 21st and 22nd of July, there will be a 2 days hack and match event completely online, where we will have several teams composed on the challenge provider, and the solution provider to further develop a path for a solution of the given challenge. So these are our five challenges. The first one is developing smart and sustainable injection molding solutions by integrating IoT, AI-driven process optimization, and advanced tuning technologies to support the industrialization of green railway components. The challenge 2 is identifying high-value applications and industrial use cases for a novel biodegradable material derived from organic waste, particularly in mobility and other sustainability-driven sectors. Challenge 3 is developing predictive and risk-based validation methods to accelerate the adoption of recycled materials in automotive components while ensuring consistent OEM-level performance and quality. Challenge 4 is developing eco-efficient management solutions to improve the sustainability, energy efficiency, and operational performance of mass transit systems. And challenge 5 is developing sustainable foaming technologies and alternative blowing agents to accelerate aluminium foam production, improve foam quality, and reduce environmental impact. So if one of these challenges is suitable for a solution you have in your pocket, please join the call for solutions. You will find the link for that in the chat. Contribution is possible until the 13th of July. After that, we are designing the teams, the 5 teams, and then the hack and match event will take place on the 21st and 22nd of July. The awarding ceremony, 2 prizes, 1 winner and 1 coup de cœur, will take place during the InnoTrans in Berlin. Also at the InnoTrans in Berlin will take place the awarding ceremony of this year's ERCI Innovation Awards. We will have 3 prizes, the best SME, the best large enterprise, and the coup de cœur, special prize of the jury. We have already 29 applications under evaluation, and we expect the result by the end of July. The jury is an international one. Every cluster had the chance to nominate 1 jury member, in total 10 or 11, and then we will see what will happen. So, InnoTrans is a good keyword. ERCI will be present also during the InnoTrans. That means certain members of ERCI are present with their own booths or parts of joint booths in several locations during the at the InnoTrans. And we are also collecting some interesting program or agenda points or events which are taking place at these several locations, and we will keep you informed during our ERCI webpage what is going on with a European perspective or with an ERCI based interest at our website. So some support for establishing European project. ERCI could support you in find interested members to participate in a consortium. We are looking for opportunities to participate in developing consortia, and we are also looking for possible lead partners of EU proposals, which is very important. It's a basic step to establish a consortium. The role of ERCI in several projects is ERCI could be a partner of a project, also a leading partner. It could be a member cluster of ERCI that is one of the partners of a consortium, and for sure also members of the ERCI members could act as partners in such projects. Some examples, you see 3 logos here, the Leader 2030 zeros and the project idealists, and that are the hot topics ERCI is currently dealing with. To give you some examples, projects tackling supply chain disruptions, boosting the advanced technologies uptake in order to modernize business processes or use cases, and creating a single European railway area of skills alliance that is, for instance, the topic of the CERES project. So, one example is the Leader 2030 project, and you might download the policy brief of this project. It was to overcome, or finding measures to overcome the gaps in supply chain for raw materials for the railway sector. And the project ended with some recommendations and the policy brief. You might download this. And also you'll find some information on the other mentioned projects also in the chat if you are interested. Please do not hesitate to follow these links. So repeating again, the next ERCI webinar will take place on 9th of September. Registration is possible. The topic is AI and video analytics for smarter rail maintenance. And then I repeat, I'm pleased to repeat the slide for having more B2B contacts coming from this webinar. I felt the webinar was very productive, many questions and many interesting presentations. And if you want to be part of the community, we kindly ask you to fill in this short slide with your information. So we will send out the collection of filled-in slides together with the presentations and the link to the recording of the webinar in a few days, maybe Monday. And thank you very much for your contribution, and also thank you very much for filling in our short feedback questionnaire. And thank you very much for your attention, and have a nice day, and bye-bye.
Thanks, Lutz. If I could just jump in, massive thank you again to Helen, Lorenzo, Guido, Antonio, and Lutz again for fantastic presentations. And also massive thank you to our delegates. I don't think I've ever seen quite so many questions appear in the chat. So thank you for your full and engaging participation. I hope you all have a wonderful rest of day. Thank you.
Thank you very much. I think it was a good summarizing of our webinar, and all the presenters, and your active contribution and active discussion was very valuable, and thank you very much. Yeah. Have a nice summertime.